Hello, good day. So today we want to look at differentiation of algebraic functions, right? Okay. The simplest form of algebraic function can be written as y, which could be written as f of x is equals to ax raised to the power n, right? Is the simplest form. Okay. Now we want to carry out the differentiation of this function from the first principle. Our formula of differentiation from the first principle is y ds is equals to, of course, f prime of x, which is another way of writing differentiation, right? So it's something as limiting value as the s tends to 0 of f of x plus dx minus f of x divided by dx. We derived it in our previous lecture, right? Okay, so we want to apply this formula now to be able to solve this problem, right? Okay, so when we have f of x plus dx, f of x plus delta x is something as putting this one in the position of x in this function, right? Okay, so we'll now write this as the limits as the s tends to 0 of f of x plus. So writing this in this format now is going to be a x plus dx raised to the power n. That is, whenever we see x, we put this x plus dx there, right? Okay. Now minus f of x. F of x is of course a x raised to the power n, right? All over dx, right? And if you look at this very well, we can do the expansion of this using our binomial expansion method, right? So this is going to be a limit as the s tends to 0. This is going to be a. Now the expansion of this one is going to be, the first time is going to be x raised to the power n, right? Then the second time will be n x raised to the power n minus 1. Then the x raised to the power 1, right? That's the second term of our binomial expansion, right? Then the third term is going to be n combination 2, that's the coefficients, right? Then what is going to be x raised to the power n minus 2, right? Then the x is going to be raised to the power 2, right? From our binomial expansion, right? Then the next term, let's see this, the last term. The last term is going to be what? Dx raised to the power n, right? So this is the expansion of this one. And this is going to be a raised to the power x raised to the power n. Everything divided by dx. Are we good to go with this? Now, this a can now open this bracket, right? So this is going to be the limits as the s tends to 0 of a x raised to the power n plus this is a n x raised to the power n minus 1 dx delta x, and this is going to be n combination 2, then a n combination 2 x raised to the power n minus 2 delta x squared, right? Okay, so plus this is a delta x raised to the power n, right? So we have expanded this with x raised to the power n, right? Dx. Are we good to go with this? Okay. Now this expansion has opened something up for us to cut. We see that ax raised to the power n and ax raised to the power n, they are the same. We can cut them out of this expression. And from here, this is going to be as the s tends to 0. Now we can now do what? Factorize dx out of this function, right? So let's factorize delta x out of the function, delta x. Okay? So this is now going to be a n x raised to the power n minus 1 plus this is going to be a n combination 2 x raised to the power n minus 2 This is what? Delta x, right? Plus the last time there is going to be delta x is about n minus 1. You know, if you remove 1 from this, it's going to be n minus 1, right? So that's the expansion there all over dx. So dx can cos dx here. Are we good to go with this? Okay, so if we now substitute this dx into this expression, it means all the terms having dx in it will become 0. Everything having dx in it will be rendered 0. From this term up to the last term, they all have dx, delta x in it. Because of that, everything will now be rendered 0 from there. So it will now become equal to a and x raised to the power n minus 1. So this is the differentiation from the first principle of y is equals to x raised to the power n, which means if y is equals to or f of x is equals to ax raised to the power n, then the y dx, which is also called f prime of x, is going to be this multiplying this, that will be a n x raised to the power n, then minus 1. So this is the fundamental formula in differentiation of algebraic function, right? Okay, so this is how we arrive at this. Thank you. Please follow, like, share, subscribe, and also comments on our channels, on our videos. Thank you.